So these are the trig identities that you're going to need to know. So make sure you spend some time memorizing those. Okay, multiplying by the conjugate. So the conjugate of root x minus 1 is root x plus 1. So if we want to change an expression like this and get rid of the radicals in the denominator, we multiply numerator and denominator by this conjugate. So in the numerator, I'm going to suggest you don't multiply it out. In the denominator, when I multiply the two root x's, I get x. Then I do the outsides, I get positive root x. Insides, I get negative root x. That's always going to happen when you're multiplying by the conjugate. And then I'll get negative 1 times positive 1, and there you go. Okay, so the conjugate here will be root x minus 4 minus root x. And you have to do top and bottom by the same thing. Okay, so when I multiply these two, I get x minus 4. And if I multiply the outsides, I get negative root x times x minus 4. And if I multiply the insides, I get positive root x times x minus 4. So those go away. And so the last term will be minus x. Root x times root x gives me x. And then the denominator, so do not multiply the denominator out. Just leave it as it is. And on the numerator, the x's cancel. So I get negative 4 over 4 root x minus 4 minus root x. And you can see that the 4's cancel even. So I get negative 1 and then root x minus 4 minus root x. Okay, multiplying by the conjugate here, let me start over here. So root x plus h minus root x. So I'm going to multiply by the positive. So I'll have root x plus h plus root x over root x plus h plus root x. So multiplying on the numerator, and again, I'm going to encourage you not to multiply out, so keep the h there. So root x plus h plus root x over, now multiplying these gives you x plus h. Insides and outsides cancel, so then I'm left with a minus x. So the two x's cancel. And so then I'm left with h root x plus h plus, root x plus h, right? Plus root x, and that's all times h, all over just an h. So the h's cancel, so I just get root x plus h plus root x. Okay, so when we're trying to graph something and we can see that there's canceling, we must cancel first. So this f of x is the same as x minus 2, x plus 2 over x minus 2. So these x minus 2 cancels, so my function is x plus 2. But it did start off like this, so I have to think about what happened when I canceled this x minus 2. So this x minus 2 cannot be 0, because 0 over 0 is not good. So I cannot use the factor of 2. I know this is a line, y equal x plus 2, so crosses here at 2. So when x is 2, right, that's where x is. When x is 2, you have to make a hole. So there's the hole. So there's a hole in the graph when you cancel. So let's do this one. So f of x is equal to x minus 2 over x plus 2. So the x minus 2's cancel, so I'm left with this. Okay, so this is like a hyperbola. The asymptote is at negative 2, so it looks like this. It's like the 1 over x graph, but there's a hole. So the hole is at x equal 2. It's the same factor, so when x is 2 over here, you have to put a hole. Can I figure out where that hole is? Yes, if I plug x equal 2 into here, that would give me the y value of 4. And if I plug x equal 2 into here, I get the y value of 1/4.